So the first thing I want us to do is a feedback on the investigation that you've done yesterday. As of 3 minutes ago, it's locked. So which means if you haven't submitted, you cannot submit anything. I need to be putting a deadline so I can share feedback with people that do the work. So if you keep waiting because I do not chase you for deadlines, then it means I don't get a chance to give comprehensive feedback to the class, especially if I'm going to put it in a more practical form. All right, so we're going to be looking at some of the questions and try to see something we can observe. Let's see, let's go to, I'm trying to open the quiz on my own personal computer. Don't worry about it, you just focus on the screen. Okay, so one of the questions says find a graded sum. So if you log on to your module later, you will see that it's graded. I should be able to grade the rest, and I put some comments. So I'm sharing the comments in general now. So the first thing you have to do is to do y is equal to, of course you don't need y is equal to x plus 3. And you found your inverse to be y equals x minus 3, or f inverse is x minus 3. And then I ask you to do y is equal to x. Or just simply plot x. You have to plot this in black, so it doesn't matter in this case. And a broken line. So this is what you were asked to do. Okay, maybe I do that. Okay? So this is one. So we plot another one, just to be sure our observation is what it is. The next one is 3 minus 2x, so I put divided first. 3 minus 2x. So in that case, we will uncheck this. 3 minus 2x, then minus 1 divided by 4 over 2. So minus 4x plus 3 over 2. That's what somebody claims to have gotten. So I believe it's right. Or it could be 3 minus 4x. It doesn't have to be minus. When you encounter minus, and the second is plus, always swap. Because some of you made a lot of mistakes with this kind of manipulation in the activity that was just given back to you. So when you encounter minus, just swap it. Just write it as 3 minus 4x instead. It makes life easier. So this is the second one. You will notice, of course, a lot of you have seen this already from your what you have sent to me. Quite impressive. You will notice that the graph of your function and the inverse are mirror images, and this is the mirror line. So all you have to say is, oh, I said comment on your observation of, what did I even put there? Actually, that's number 6. So question 6 says, observe the graph of y equals f of x and f inverse of x on the same axis, blah, blah, blah. What do you notice? That I said, think about the geometric relationship between f and f inverse and the role of y is equal to x. That was, I even gave you a guide. So, what I noticed is that, they are reflections of each other, and y equals to x is the line of reflection. Or, the graph of f inverse is a reflection of the graph of x along the line y equals x, or about the line y equals x. Some will probably put it as, y inverse of f inverse is the reflection of f, the graph I mean, not f inverse. The graph of f inverse is a reflection of the graph of f, and the mirror line is y is equal to x. So if you want to say it like someone in middle school, we will allow that, as long as the key points are mentioned. That one is the mirror image of the other. You don't use the word mirror image per se. Just say reflection. That's a more matured way to put it. Of course, that's what we will tell someone in middle school or P6 or mirror line. Okay? Mirror image. But you know what it's called. It's called the reflection. Okay? So they are just reflection of the other. If you draw f inverse first, all you have to do is draw the reflection to draw the f. If f is given, you do the reflection to get f inverse. Remember, inverse of an inverse is the function itself. You figure that out yourself, right? So to get the inverse is going to find the reflection of that, that graph. Which means to get the inverse of an inverse, you just find the mirror image of the inverse. Is that not? And that gives you back the function. So all these things are kind of connected. So that is the comment I expect. Now, I will put the rational function and then finalize the explanation. So this can also be seen here. If you look at it, okay? Can also see the same. So for the rational function, I gave you 2x minus 9, so let's say divided first. Divided by 3 minus x. Okay, you can go. Then the inverse was found to be negative 3 over negative 2. See, the way some of these things are written are quite complicated. Why would you do that? Negative 3x minus 9, somebody did this. The minus 2 minus x. Why? Who can tell me what is the best way to put this?
3x plus 9 over x plus 2.
So what can this person do?
Take out all the negatives.
Take out the negative. Just factorize. Just factorize negative here, factorize negative here, and cancel. And negative in all the forms. It's like having so much blood. It's irritating, you know? Alright, so the best thing I would expect is just plus. Something like this. It's better. Alright, so with this, clearly we can see the relation again. So if the function is the red, if this was an exam and you are given the red one only, let's remove the blue. Let's deactivate the blue. And you are given only the red, you find the mirror, the image. If this is the mirror line, so you consider this part, then you realize, okay, the image of this will have to go this way, right? The distance have to be the same. You understand that? And the image of this will have to come this way. So you can see this comes here, so the image of this will come this way, like that. Understand? Because in IB exam, I'm going to, when I test you, I will use real past question, of course. If you are given the equation, it's easy to use your knowledge of, what's it called? Your knowledge of rational function to sketch. You know, somebody can just decide to find the inverse and quickly use rational function to sketch. And in fact, if calculator is allowed, quickly put it in your calculator, see what the shape looks like, draw it. So they are very smart. They won't give you the equation. They will just draw it for you and ask you to draw the graph of the inverse yourself without knowing what the function looks like. That is the reason we are studying this investigation. Understand? So all you have to do is, you know, just reflect every part of the graph. So clearly there are 4 parts because of this reflection line. One part is here, it has to be reflected here. One part is below, it has to be reflected here, right? One part is here, it has to be reflected here. This part will have to be reflected here. Do you understand what I mean? I'm not sure if I put it right. So let's see. Okay? So you can see with this mirror line, these are reflections of each other, these ones. This blue and these are reflections too, like that. Okay? This one and this part are reflections about this. And this part and this part are reflections, so you need to be very careful when you draw. Okay? Was it question 4? So I'll take question 4 as the last one. Question 4 also is 3x plus 1 divided by x plus 2. And the image was found to be 2x minus 1 divided by 3 minus x. So you can see this also. Uh-oh, reset this. No. Okay. Look at that. I was trying to enlarge the middle part. And you say, look at the middle part. Let's even start from the middle part. Perfect reflection, isn't it? And of course, there is some part that is outside that, and that is also reflected about the same distance. Okay? It's a sketch. It doesn't mean it has to be measured, but at least commonsensically it should be sketched. If this is here, you don't put the reflection here, like it's too close. It should be as far as this is as well. Okay? And if this is coming this way, it touches here. That is when the other one comes as well. If this comes this way, this will go this way, like that. So you have to be creative yourself. And one other thing I ask here is the asymptote. For the original function itself, you will notice that when x is equal to minus 2, because the original function is the red one, isn't it? What about the horizontal asymptote? That is 3 over 1, which is 3, y equals to 3. So let's put that in red and broken line. So we know they are for the original function. Okay? Okay?
Yes.
So this is for the original function. Now for the inverse now. If you look at this inverse, this is when x is equal to 3, right? And y will be, you divide numerator coefficient of x by coefficient of x in the second one, right? So that is 2 divided by minus 1, right?
Yes.
Which is y equals to minus 2. Understand? So, if this is blue, we can put this also in blue. So let's remove the functions. So actually, one after the other. If you look at the function, of course we have taken care of the reflection, but if you look at the behavior of the, somebody said the asymptote interchange. That is not, how do I use it now? That is not, I don't want it to talk like that. What do you mean interchange? I think the person just say, oh, they interchange. Who are they? My classmates? Okay? Who interchange with who? So that's not a good way to put it. Of course, I gave the, that doesn't mean the candidate gets lesser mark or something. All the graphs were perfect, so I gave the person a 7 and I wrote a comment about how to put it. Okay? So I would expect you to say, oh, if the graph of, if the vertical asymptote, because if you look at this, the vertical asymptote of the function is x equal to minus 2. And that is the, that's a minus 2 is horizontal for the f inverse. That's what this person meant by the interchange. But who is they? We're talking about the function, the inverse, the 2 asymptote for the function, the 2 asymptote. So there are 6 things. So who exactly is interchanging and with who? Even if we are to accept this language, they interchange, make sure we are only talking about 2 things. So if you are talking about Alex and Yanko, they interchange their textbook. I don't have any reason to be thinking of Anika. Because you are the subject of discussion involves those 2 people. But here, there are 6 things. And the only comment you put is the interchange. Who interchange? What exactly did they interchange? Money? Do you get that? So please, try to be able to write something that will present itself even if you are not there. Because you were not on my desk when I was checking and grading. So imagine if this was IB. Are you going to ring your phone and say, oh, what do you mean when you said this in your exam? Nobody will do that. So you need to present your argument in a way that it speaks for itself. Okay? So, if you look at it, this is what the person meant by the interchange, and of course this one as well. So a mathematical way to write it, to me, will be, if the vertical asymptote, remember you're speaking in general, if the vertical asymptote of the graph of f, or of the function f, is x is equal to a, then the horizontal asymptote of the inverse will be y is equal to a. Remember, vertical is x, horizontal is y, but the same a comes back. And similarly, if the horizontal asymptote of the function is y is equal to b, then what? The vertical asymptote of the inverse will be x equals to b. That's a very good way to present something. Not the interchange. Who are they? Okay? So, well done. So let's picture that again. So clearly you can see y equals 3, x equals 3. And here when you have y equals minus 2, this gives x equals minus 2. So this is the interchanging, because these are the lines. You see, even this line reflects as well. That's where the interchanging comes from, but you need to present something better. Does this make sense? All right. So the worksheet that I have for you today, one other thing. Let's see how you can identify a self-inverse function. Okay, I think I'm going to do this format. One function that I ask you to do, remember function h, 7 minus x, right? Remember that? Yeah. This is how you know it is self-inverse. Because if you reflect it, it's exactly the same thing. Remember, the reflection is the inverse, right? When you reflect, what difference does it make? That is the meaning of self-inverse. Reflect this line, you get this. Oh, I was about to reflect this and it's already drawn. Okay? So if I give you a picture and I said, tell me what you can say about this graph. This is the graph of a function. Just draw your line y is equal to x and see if this is a reflection. If it is exactly the same thing, number one thing I can say, it is linear, right? And it is a self-inverse function. Do you understand? If I don't need the equation, you don't put the equation. In fact, if I'm giving you something like that, I'll probably remove all the axes so you don't know the intercept. So if you don't know the intercept, how do you write the equation? Understand? Yeah. Those that are sleeping in class might be kicked out so they can have a good nap outside. So if you are sleeping in my class, I'm likely to kick you out any moment from now. Give me the last function f in the worksheet that I just gave you. The last function f. So that's another self-inverse function, something like 8x or something 8.
So 3x minus 8.
3x minus 8.
Over x minus 3.
X minus 3. Now let's see why this is also self-inverse. Can you see? Self-inverse. This is the function. If you want to, there are 4 parts, right? If you want to find the mirror of this part, it's already here. Which means if you find the mirror of this, is this again. If you want to find the mirror of this, is here. So, this is a self-inverse function. And this is a rational function. Because there is asymptote. You can see vertical and horizontal asymptote. So you know this is a rational function. Any questions, please? Okay? So if there's no question, these are from your book, and some of them that I created myself, so I put it together. I use the same thing for the last year, Form 5. So, and I want you to start looking into, so basically, Alex, I'm going to ask you again, and maybe Yanko. Here we are. So, I will be saying what I want you to do. Let's focus, please. Thank you. So I need you to, oh, I'm actually opening elsewhere. I thought I was projecting my personal computer. Do I have it in my office computer? I should. Compile, copy to. I think I have it. So you may start if you know what to do. I can't hear what you say. Yes, you can. And why is your computer on? Please.
I want to check where is.
Okay.
Correct.
So this is what you've been given. So you can see in every function, sometimes I give you the intercept. If the intercept is indicated, any point is indicated, please indicate the corresponding one as well. Okay? So for each of these, please do the inverse neatly, but a sketch. Neatly, but a sketch, please. I think this is from IB. This particular one is from IB. Anyone that is color coded is, I got it, I created something on decimals, but this is from IB. I'm not sure. Then others are from your textbook. So that's the activity for today. Let's put on the light. Joey, I think we're done. Oh yeah, one other thing before we turn off the camera. I think it was Mr. Oyi, yes. He said something about a way of finding inverse. And I talked to him and maybe one other person that yes, it's correct. Was it you and Elsin? So please, if you want to use that approach, please you are welcome to do so. Alright, because that works as well. The only limitation I have is that it might be confusing when doing inverse of an inverse. So to write it might kind of complicated, but if you are able to work around it, it's fine. I'd like to share what they said with the class. So please, please pay attention here. Everyone, please pay attention here. So if, let's say you have function f of x is equal to, let's take a simple function, 3x, let's say minus 2 for example. And you want to find the inverse. You want to find inverse, okay? So rather than say let y be f of x, like I told you in the class, another way is to say, okay, whatever I'm looking for, let it be y. So what I'm looking for, remember this is the destination, f inverse of x. Let it be y. So if I'm able to get y, I'm done. And of course from here, the implication is that x is equal to f of y. Okay? So because f is f of y, so x, this x is equal to f of y, means x is equal to, from f of x, you can write f of y as what? 3y minus 2. Remember, you need y, which is what you are trying to get. So which is x plus 2 is equal to 3y. Then here x plus 2 over 3 is equal to y. And this y is the inverse that you're looking for. Okay, so if y is equal to x plus 3, or x plus 2 over 3, sorry. Yeah. Then y, which is your f inverse, according to your supposition, gives you the final result. So if you understand this method, when I give you work to do or text or whatever, well, you're welcome to use it. But I need to see what you are using. Remember, if you let the final answer be unknown, then you can interpret it this way. It is this interpretation. It is this interpretation that is then used. So here I say because, the reason for this line, because f of x is equal to 3x minus 2. So f of y will also be 3y minus 2. We only repeated the left-hand side, and we interpreted the right-hand side based on the definition of f. And you let here, remember, it is find f inverse. If f is this. Find f inverse. Oh, what I'm looking for, let it be y. interpret that, you get it. Your left-hand side, because of this definition of f, and you just make y the subject. Once you are done making y the subject, that is your f inverse. So it's direct. But you want to be really careful in the question that asks you for f inverse of x, something like this. Again, it shouldn't be difficult, but you have to be very careful. But for you to do this, you must have known your f inverse of x. Maybe for this particular question, f inverse of x is x plus 3, x plus 2 over 3. Right? If I need the inverse of the inverse, so I can say, oh, let the inverse of my inverse be, instead of y, maybe some w. Then, one inverse goes away. F inverse of w must be equal of x. Am I right?
Yes.
Must be equal to f inverse of w. So the problem is manipulating this. Of course, you can do it, but rather than putting yourself in this situation, you can just go the other way, the first method. But this also can be done. Because if the inverse of this inverse is this, it means if we need, if I need my x to be isolated, I will have to find the double inverse of that as well. But then how do you find the double inverse that you have not done? Do you understand what I mean? So the only confusion might be when you are trying to solve a problem like this, which is hardly given. It can be done, but I want to believe it can be confusing to some of you. But if it is just a single inverse problem, you are welcome to go straight into it. So what most of you did in the class activity is let the inverse itself be maybe some h. Then you did x of x is equal to f of h. Is that not? Is this what you did?
No. This is the same method as the other one.
Oh, yeah. Okay, this is the method as the other one. Okay. Remember, we are finding the inverse of this, right? So you did let f inverse of x is equal to h or w. Then you say the inverse of this one. Yes. So x will be equal to inverse of h, like this. This was what you did. Understand?
Yes, yes.
So I just wanted to mention that. Then one other thing that I didn't ask you to prove, you might want to check it yourself. I want you to check. Of course, some of these things are probably only useful for the HL students, but it's good to have the idea. I want you to check. G composed with F, if you find the inverse, can we say it is G inverse composed with F inverse, or is G composed with F? Which of them? Is this equal to this or this equal to this? So that's one question I didn't put in the activity where you found these properties. Some of these properties you probably don't need them until university days. It's just part of you just having some knowledge of something you probably don't need now. Understand? So please pick any function, f and g could be the ones you have already done, and try to find, not now of course, this is just your own investigation, and try to find one of them is correct, one of them is wrong. Alright? Thank you. Ms. Joey, I think that's all. Thank you.